Okay, so today we're going to dive into something that's like super important.
Yeah.
If you're prepping for a senior software engineer interview,
Right.
and especially if you're going to be talking about distributed systems.
Yeah, for sure.
And that is how all these different microservices out there actually talk to each other.
Yeah, definitely.
And this isn't just about like, knowing the names of the different ways.
Right.
It's like understanding, like when to use what and
The trade-offs.
the trade-offs. Yeah, exactly.
Absolutely. And you might be familiar with some of these terms already, like asynchronous communication, REST message queues.
Right.
But the key is to be able to really explain why you'd choose one approach over another in a specific situation.
Right.
And, think of this deep dive as like a way to sharpen your skills so that you can really impress those interviewers.
Yeah, and not just answer the question, but like show them that you actually understand how these systems work.
Exactly.
So we're going to break down like the main ways that microservices can communicate, and we'll look at each one in detail.
Sounds good.
So first we'll start with synchronous blocking communication.
Okay.
Then we'll move on to asynchronous non-blocking communication.
Got it.
And finally, we'll talk about common data, which is kind of like a sneaky way that microservices can talk to each other.
Interesting.
So let's kick things off with that first one, synchronous blocking communication.
All right.
What exactly does that mean?
So basically it means that when one microservice needs to talk to another one, it sends a request and then it just waits.
Okay.
It can't do anything else until it gets a response back.
It's blocked.
Exactly, it's blocked.
Okay.
And the most common way this works is through something called a request-response pattern.
Right.
One service asks a question, another service provides the answer, and the first service just has to sit tight and wait for that answer.
Okay, so like in a real system, how would we actually implement this?
Sure. So there are a couple of popular ways to do it. The most common one you've probably heard of is REST over HTTP.
Oh, yeah.
This is where a client service makes an HTTP request to a specific endpoint on another service.
Okay.
And then it just waits for the HTTP response to come back before it can do anything else.
Right.
Another big one is RPC, which stands for Remote Procedure Call.
Okay.
The idea here is to make it feel like you're calling a function on a remote service, just like you would call a local function.
Interesting.
So even though there's all this network communication happening behind the scenes from the developer's point of view, it's a simple function call.
Got it.
But it still blocks until it gets that response.
Okay, so REST and RPC. Those are definitely things I've heard come up in interviews.
For sure.
Now, I've also seen systems that use queue-based brokers.
Yeah.
And it almost seems like they're using them in a synchronous way.
Right.
Can you explain how that works? Because usually queues make me think of asynchronous communication.
Yeah, that's a great point. So while message queues are mostly used for asynchronous communication, they can actually be used to create a synchronous request-response flow.
Okay.
So in this pattern, the requesting service sends a message to a special request queue,
Okay.
and then it patiently waits for a response message on a separate reply queue.
Right.
The service that picks up the original message processes, it does its thing, and then sends the response back to that reply queue.
Got it.
So even though we're using messages, the initial service is still blocked.
It's still waiting for that specific response.
Exactly.
That's a really interesting distinction to keep in mind.
Yeah.
So the key takeaway here with synchronous blocking is that the service that starts the conversation is basically stuck waiting for a response.
Yep.
Before it can move on.
Exactly.
Okay, so let's shift gears now and talk about something that sounds a lot more flexible.
Sure.
Asynchronous non-blocking communication.
Okay.
So how does that work?
Well, unlike synchronous communication, where things are blocked, asynchronous communication lets a service send a message or trigger an action in another service without having to wait for an immediate reply.
Okay.
It's kind of like when you order something online, you get a confirmation that your order was placed, but you don't just sit there and stare at the screen waiting for the package to show up.
Right. You go do other things.
Exactly. You go about your day.
Yeah.
And in this world of microservices, the main style of collaboration is event-driven.
Event-driven. So what does that look like in practice?
So in an event-driven system, services publish events whenever something important happens within them.
Okay.
Like, let's say an order is created, a payment fails, or a user's profile gets updated.
Right.
These are all events.
Okay.
And other services that are interested in these events can subscribe to a specific stream or topic of events.
So it's like they're choosing what they want to listen to.
Exactly. And when an event is published, the broker or intermediary makes sure that all the interested subscribers get a copy of it. The cool thing is the service that originally published the event doesn't even need to know who's listening or if anyone is listening at all.
Right.
This creates a very loose coupling between services.
So they're not directly dependent on each other.
Exactly.
That sounds like a really good thing in terms of making the system more resilient.
Absolutely.
So what are some of the common technologies that are used for this event-driven approach?
So one popular option is to use topic-based message brokers like Apache Kafka RabbitMQ in a pub/sub setup, or even cloud-based messaging services.
Right.
These allow services to publish events to specific topics, and then subscribers can consume events from the topics they've signed up for.
So it's like a really organized way of broadcasting and listening to messages.
Precisely.
Okay.
Another approach that we see sometimes is using REST over HTTP, but with a twist.
Oh, interesting.
We can adapt REST for asynchronous communication using things like Atom feeds.
Okay.
So a service can basically expose a feed of events, and other services can periodically check this feed for any new updates.
So it's still using HTTP, but it's not like that direct back and forth conversation.
Trust me, it's not blocking.
Right. It's more like checking a news feed.
Yeah, exactly.
Okay, that makes sense.
Yeah.
So the big difference here is that the initiating service doesn't have to wait for an immediate response.
Right.
It can just keep doing its own thing.
Exactly.
Okay, so now let's talk about that third category you mentioned, common data.
All right.
When we were first looking at the outline for this episode, this one felt a little different.
Yeah, it's not always thought of as communication in the traditional sense,
Right.
but it definitely serves that purpose.
Okay.
So the common data approach is all about microservices interacting with each other through a shared data store.
So instead of sending messages directly, they're communicating through the data itself.
Precisely.
Okay, can you give us some concrete examples of how this would work in a microservices world?
Sure. So imagine a scenario where multiple microservices are designed to work with the same database. One service might update a specific record, and another service, by reading that same record later on, would automatically become aware of that change.
So they're indirectly communicating through the database.
Exactly.
Okay, what about something other than a database?
Well, another option is to use a shared file system.
Okay.
So one service might write a file with some information, and another service can then read that file to get the data.
So it's like leaving a note for someone to find later.
Yeah,
Yeah.
kind of. But while these approaches can be simpler to set up initially, they often come with some downsides in terms of tight coupling between services and figuring out who really owns the data.
Right, that makes sense. And in terms of communication style, this is generally asynchronous and non-blocking, right?
Exactly, just like the event-driven model.
So each service is working with the shared data at its own pace.
Yep, they're not directly waiting for each other.
Okay, so now here's the big question. For someone who's getting ready for a senior software engineer interview,
Yeah.
just knowing these three categories isn't enough, right?
Definitely not.
You really need to understand when to use which one.
That's the key.
So what are some of the factors that should guide that decision-making process?
So first and foremost, think about reliability. If a service absolutely needs to know for sure that its request was processed successfully, then synchronous communication might be the way to go.
Because you get that immediate confirmation.
Exactly.
Okay, what else?
Well, you also need to think about how much latency your system can tolerate.
Right, because with synchronous communication, the calling service has to wait.
Precisely. And that waiting introduces latency.
So if you need things to happen in near real time,
Yeah,
that blocking can really slow things down.
absolutely. And it can impact the user experience.
Right, because nobody wants to wait for a slow website or app.
Exactly.
Okay, what about the number of interactions between services? Does that matter?
It definitely can. If you have a ton of synchronous communication happening, it can put a lot of stress on your services and your network.
Right, like everyone's waiting for each other.
Exactly. Asynchronous approaches, especially event-driven architectures with message brokers, tend to handle high volumes of communication much better.
Okay,
They can scale more easily and are more resilient under pressure.
got it. So earlier you mentioned that a good starting point is to decide between a request-response style and an event-driven style.
Right.
Can you talk a little bit more about that?
Sure. So if you're dealing with a situation where you need to ask for specific information and get an answer right away,
Yeah.
like a classic query and result pattern, then request response is often a good fit.
Like checking if a user's credentials are valid.
Yeah, exactly. Or fetching product details from a catalog.
Right.
But if you're dealing with changes in state or events that might be interesting to multiple services and the original service doesn't need an immediate response,
Okay.
then an event-driven approach is probably a better choice.
So like when a new order is placed.
Exactly. That could trigger inventory updates, shipping notifications, and even analytics logging.
Okay. And once you've decided to go with a request response style,
Hmm.
you still have to choose between a synchronous implementation like REST or
Hmm.
RPC,
Right.
or potentially an asynchronous implementation using queues like we talked about earlier.
Exactly. You've got
And
options.
if you go with an event-driven
Mhm.
style, you're pretty much stuck with asynchronous and non-blocking options.
Yeah, for the most part, although there are some less common hybrid approaches out there.
Right. It's always good to know that those exist.
Definitely.
Okay, so we've talked about the communication styles themselves, but it's also important to remember all those other factors that come into play when you're designing a system, right?
Absolutely.
Like how fast things need to be security considerations and whether the system needs to be able to handle a lot of traffic.
All crucial
So, for
factors.
example, if you absolutely need the fastest possible response times for your request response interactions,
Right.
you might choose a specific RPC framework that's known for its speed. And if security is a major concern, you might need to use HTTPS with mutual TLS for your REST APIs,
Mhm.
or figure out how to encrypt the messages in your queues.
Yep.
And of course, if your system needs to be able to scale to handle huge numbers of users or requests,
Right.
then that will influence your choice of message broker or how you design your API gateways.
Absolutely.
So it's not just about picking a communication pattern in isolation. It's about understanding how all these different pieces fit together.
It's all interconnected.
Okay, so you mentioned earlier that microservice architectures often use a combination of these different communication styles.
Yeah.
Can you give us a real-world example of how that might look?
Sure. Let's go back to that e-commerce platform we were talking about before.
Okay.
Imagine a customer is checking out and they're about to place an order.
Right.
The front end of the application might talk to an order service using a synchronous request response API,
Okay.
maybe REST over HTTP to make sure the order is placed successfully and to give the customer immediate feedback.
So that's the synchronous part.
Exactly. But once the order is created and saved, the order service might publish an order created event to a message broker.
Okay.
Now, other services like the inventory service, the shipping service, and maybe an analytics service can all subscribe to this event,
Got it.
and they can each do their own thing in response to that event.
So it's like a chain reaction, but without everyone having to wait for each other.
Precisely.
Okay, that's a really clear example. So the same microservice can use synchronous communication for one specific purpose, like placing the order,
Right.
and then use asynchronous communication for other related tasks.
Exactly. It's all about using the right tool for the job.
And this hybrid approach gives you a lot more flexibility.
For sure, it makes the system more resilient and scalable.
Okay, so to wrap things up, we've covered three main categories of inter-microservice communication.
Yeah.
Synchronous blocking, which usually uses the request response pattern, and things like REST and RPC, where the caller has to wait for a response. Then there's asynchronous non-blocking, which often uses an event-driven style with topic-based brokers, where services publish events and keep going.
Yeah.
And finally, we talked about common data, which is also asynchronous and non-blocking, where services communicate through a shared data store like a database or a file system.
Exactly.
And I think the most important takeaway for anyone preparing for a technical interview or even just working with distributed systems
Sure.
is that choosing the right communication style depends entirely on the specific situation.
Couldn't agree more.
You need to think about things like reliability, latency, and how much communication is going to be happening.
And absolutely.
And often the best solutions use a combination of different approaches.
A mix and match.
Exactly.
Mhm.
So as you're prepping for those interviews,
Yeah.
think about the systems you've worked with or the ones you know about.
Right.
Can you identify the different microservices in those systems and figure out how they're probably communicating?
It's a great exercise.
What were the reasons behind those design choices?
That's what will really make you stand out.
Being able to analyze and think critically about those choices,
Exactly.
that's what will show the interviewers that you truly understand these concepts.
And that you can apply them in real-world scenarios.